Well, yeah, thanks for that, and thanks for this opportunity to speak today. You know, David mentioned the Alexa, so it's probably worse than you think. I heard that if you have an internet-connected speaker in your house, that you can hack that speaker and tell Alexa to unlock your security alarm, and there you go. So
yeah, sure.
Let's see. Let me get. So which button is it? Is it red? That's the laser.
I left my bag up there.
Far right.
Yeah, sorry.
So, okay. So I've been somewhat locked away in Shell and capital projects over the years.
Wait till he finishes.
And I've got an IT background and an engineering background. So, but I've found myself working within Shell in this OT space and specifically the cybersecurity space. But within projects, I've been working, delivering automation systems and making sure that they're, engineered in a way that meets our controls within Shell. So a little bit about Shell. We have 4 lines of business. We have upstream, downstream, integrated gas and new energies, and projects and technology. So at upstream, we explore and produce oil and gas reserves. And downstream, we convert crude oil to various products and market them and sell them. And in integrated gas, we compress and transport natural gas and produce a range of gas to liquid products. We also have our projects and technology organization. And so they're responsible for delivering our projects. We have this funnel of projects almost all the time going on, and our P&T organization delivers those projects into the lines of business. They also provide, they do the R&D function and deliver technology or new technology into the business, and also have a range of experts that can do consulting for the business, among other things. So, so my presentation is about how do we manage our ICS security risk within Shell. And throughout the presentation, I'm going to use a term because I can't shake it, PCD, or Process Control Domain within Shell. It really means ICS, but it's the domain that we house our automation systems in, as opposed to the office domain. And yeah, so I'll make sure that was clear because I'll probably be saying that throughout the presentation. So this slide is intended to show that to manage this risk, it's not just about technology. It's about a process, and it's about a mosaic of other components to support the process. And we have leadership for accountability. We do have technology. We have these stream of projects coming in that we have to make sure they're secure and handed over. We have reference architectures that we work with our suppliers. We have an assurance model. We have a lot of collaboration going on these days between IT and engineering. We have standards, recommended practices. We have a large workforce, and we have a community of practice around that. So within Shell, we've been on this journey probably more than 12 years, and I've been involved in it for probably 10 years. And I would say that we're on the beginning of a new phase on this journey within Shell. And that's because with some of the recent acquisitions and so forth, up until now, each line of business has had its own business management system. And so I think it was the CEO said, that's not good. We need to identify those common processes across each line of business, standardize those processes, and roll them out in a new business management system for all these lines of business. So that's what's happening, and the process for managing this ICS security has been identified as one of those processes. So that's going to be a standard process across all the businesses. So another interesting fact is that we're calling it Managed PCD Integrity. So there's no IT in there. It doesn't say security. Even though security, integrity is one of the components of the triad, right? But the purpose for using integrity is to link it to the traditional asset management processes that they've been doing for decades. They run HSC, HAZIP, HAZOP, all that. They understand the word integrity. And so we want to make sure that we're linking that. This is just another category of threats to the asset, so let's manage it that way. So the way it works is that at a site, we have this process in place. It's supported by a number of roles. The first role is a site focal point. So the site focal point is responsible for deploying the controls and sustaining them over time. Also, there is a site process owner. So that's an accountability role to make sure that, and maybe it's across more than one site, but they're responsible or say accountable for the process operating correctly at the site. And then they're supported by a cross business leadership team. So we have a group that is responsible for the health of the process across the lines of business within this new management system. So the process is also supported by standards, best practices, an assurance model, and a few other components. So standards, again, we've been on this journey a long time, and so we started out with trying to figure out what would be in our standards, and within Shell, we've got a lot of central standards how we do things, and this is one of them. But, excuse me, but recently we've been trying to align that with the external standards. So we have, we're choosing to align with the IEC 62443. Seems to be the a complete set of standards we can align with, and also the NIST cybersecurity. So within our documentation, what we're finding ourselves doing is we'll select requirements and then we'll organize them according to the NIST categories. And also another theme of this is that engineering and IT are working together. So we are collaborating, and for example, we have a collaborative team of both IT and engineering that work together to come up with these internal standards and best practices. So the standard contains a short list of things that are mandatory for every site. And then the best practices is a lengthier set of things that the sites can choose to do. You're expected to do most, if not all of it, but they can choose to select the best practices based on their site risk profile, because it's not the same across Shell. And we have found ourselves in the past saying that the Shell or the risk at every site is the same. You just do this stuff, and some sites are overdoing it, and some sites aren't doing enough. So some additional roles. So I mentioned the site focal point, but there are a few additional roles within Shell that support the process. So we have technical authorities, and they're responsible for the assurance role. So within a line of business, the TAs would support the site focal point. Now, in some cases, the site focal point actually might be a TA. But the TAs are there to assure, like, management of change. We're making changes at the site, make sure that they're thinking about that and following our standards and best practices about how we implement those changes. Also, within projects, technical authorities have a big role in projects. So we're always delivering projects in the business, and so we make sure that there's a TA in there. And projects are also document-centric. It's a lot of documentation. And in those documents are our designs for how we're going to implement the automation system as well as the security controls. So the TA is in there to make sure that, that those documents are assured and that we're doing the correct designs. Subject matter experts. So there's folks across Shell that have gained a lot of expertise in this domain. And so those folks are identified and expected to spend some amount of their time supporting the process, supporting the TAs, supporting the site focal points, and so forth. PTE, or Principal Technical Expert. So within Shell, there's a variety of disciplines like electrical, civil, mechanical. Managed PCD integrity is one of those. So for each one of those disciplines, there's maybe one or two of these PTEs. They have various responsibilities, but part of it is to ensure the health of the SME community, that we have enough SMEs and enough TAs to do the job across Shell. Assurance model. So within Shell, we have a three-tier assurance model. We call it LOD, and so, or line of defense. And so the first level is where the bulk of the work occurs, and it contains or it's composed of mostly the continuous processes that sites do. There may be periodic self-assessments, but it's in things like walk-arounds, health checks, go-sees, but it's all those administrative things that you would do to sustain your controls over time. And that's a continuous process. Level 2 is a somewhat more independent review or assessment, driven by our internal IT IRM department. And so there's some tooling that assists them with assessing the site, and they may bring in some additional TAs, but it's a external or a somewhat more independent assessment of the site. LOD 3 is, I would say, almost a totally independent assessment of the site by our Shell internal audit group, and they basically report directly to the shareholders. Technology. So in the past, at this forum, we've had some folks talk about our technology in detail, but I chose not to, and we're going to talk a little bit about it here, but it's not really just about the technology, like I said earlier. So it's called Secure Plant, and it's a collaboration between Shell, Cisco, and Yokogawa. And it's basically delivered as a managed service. And so some Shell staff plus Cisco and Yokogawa manage this IT or managed service for Shell. We're about, I would say we're 80% plus on the rollout. And that's one of the things I'll talk about as a challenge. Shell is so large, it literally takes us years to get technology rolled out across all the sites. But so this technology, there's a few things that it helps us automate for the process. The first is asset inventory. So in a sense, it automates things, but we have to manually enroll like Windows boxes and let's say mostly the network equipment, like Cisco network equipment. We enroll these things into the system, but then once that's done, the system keeps up with all of the software inventory and attributes about what version of iOS we're running, hardware versions we're running, and so forth. But again, we can't see everything. We can't even enroll everything in the asset management or in Secure Plant. So there's a manual process to pick up. We still have islands of networking out there that we can't get to. So there's a manual process to load that in as well. Operating systems and operating system and patches. We have a lot of suppliers that we work with, and many of those we have agreements in place to provide us with qualified patches. And so Secure Plant helps us distribute those patches down to the sites, but it doesn't install them. It's still up to the site focal point to install the patches, using the site MOC process, work permits, and so forth. Access control. The process control domain is where these systems reside, these automation systems. And then in our office domain or possibly a vendor may want to access a system, maybe for maintenance or support. And so at the boundary of our process control domain and the office domain, we have a component of Secure Plant, we call it Secure Site. And well actually, Secure Plant portal, they log into this portal and then we have two-factor authentication mechanism to authenticate the user, and then they can log into the system within the PCD. So that's the authentication piece. Antivirus, Secure Plant does help us automate antivirus. It's somewhat more automated than the patching process. These antivirus signature files come in so fast. They roll in, and they're essentially automatically deployed out to the clients. Event log management, that's something that we're making some progress on now. So from a detect point of view, we really haven't got really good technology yet. But so our first step is event log management. So we're collecting all the event logs from Windows boxes, network gear, and we have a robust cyber defense group within IT. They take care of the business domain, and they have some tooling using Splunk that they can process these logs and look for those needles in the haystack that may indicate something's going on, and we need to follow up with an investigation. So right now, we're doing that integration project, and we're shipping those log files up to that cyber defense function. We're also investigating, sort of the next step for us is looking at network traffic analysis. So we are looking at some tooling around that at some point. We have some other technology in addition to Secure Plant. We call it PCD hosting. It's sort of in a pilot phase right now. But, excuse me, so in the past, the business has been deploying various miscellaneous applications, functions at level 3 of what we call the ISA 95 or Purdue model. And so they'll deploy the operating system, the hardware underneath that, so the hardware stack, the operating system stack, and the applications, and have to manage all that. And across Shell, that's a lot of stuff. And so the idea here is that we can provide an IT service, a managed service, to provide the hardware stack and the operating system stack, and then the business would just deploy their applications and manage and support that.
Sounds good.
Reference architectures. So within Shell, I broke this up in that we have major suppliers and what I call minor suppliers. So our major suppliers, when we do a project, they'll provide the main DCS, the fire and gas system, the safety system. But to round out a typical automation system, we have to add in these, what we call third-party packages from these minor suppliers to round out the entire system. And often, that has to be integrated to the DCS. So with our major suppliers, we work with them and we develop a toolkit. There's a lot of things that we want to do in a consistent manner with our suppliers. And this toolkit houses the agreements on how we do things, such as standard ways we use function blocks. But in this case, we also standardize upon a reference architecture. A network diagram or several network diagrams with some narrative to go with that, how we deploy our systems, and how we architect our network, basically the zones and conduits in the IEC standard. Additionally, we try to standardize on how we integrate third parties. So we'll work with the third parties, and we'll agree upon exactly how we do the integration to the DCS. Whether it's Modbus TCP or Ethernet IP, whether there's firewalls there or whether there's not firewalls there, and a variety of other things. Another point here is that, once again, we are collaborating with IT architecture in this case. So we'll bring in some IT architects that help us on the engineering side to figure this stuff out. And so it's engineering and IT and the supplier working together to do these reference architectures. Let's see, did I miss anything? Nope. Okay, workforce. So we have a large workforce. You mentioned all those roles, site focal points, BTEs, SMEs, TAs, and so forth. We also have the folks that are delivering the services and IT services. Those folks are dealing with our PCD in a way as well. So within Shell, and this is the same for not only this discipline, PCD integrity, but across Shell, all the disciplines have a workforce development process. And so that enables an employee to have a way to, there's a gap assessment tools that it can figure out for a given role, what is my gap in knowledge, and then start trying to close that gap. So, but realistically, that means, in this case, this is a hybrid workspace. You need IT skills and you need engineering skills. So how do you get that? Well, basically, you got to do some IT projects, which that's, in my case, I've done IT projects in the past and engineering projects. So maybe you spend some time in IT working in IRM. You're learning about things, business risk management, cyber threat and vulnerability management, and those things on that list there. Then you may work on an engineering project, maybe delivering a capital project, and you pick up some automation skills and learn that space. Then you learn about industrial networking and architecture, safety systems, fire and gas systems, industrial protocols, et cetera. And then you end up over time, and that's part of the challenge. This does take time. You end up with a skill set that can be brought to bear in this space. Awareness campaigns, sort of related to this is awareness campaigns. So we do have, we have the ongoing, our IT, business domain campaigns all the time. You even get these tricky phishing emails, get caught by that once in a while. But in the OT space, we also have awareness campaigns. We have some training material. We have signage. You go into a typical site within Shell, and there will be some signage about reminding you that think about security. And so we do have that component as well. community of practice. So again, we have this large workforce, and we want to make sure the workforce is behaving as a community, essentially. And that means sharing ideas, doing things in the same way, using our repository of lessons learned, not repeating the same mistakes over and over again. It's a challenge, and I'll talk about that in the challenges. But we'll do things like quarterly, bi-monthly, or quarterly meetings where we bring all the insight focal points together and the TAs. Maybe we have a dedicated meeting for the TAs, talk about assurance issues. And there may be some regional or local meetings where, like I've been hosting in the past, just the guys in the Americas, and we talk about the projects we're working on and working through what are the challenges. And there's a few channels. Well, we have forums. The idea would be I can ask a question, and then I can get some answers from the community to a particular problem I'm working on. And so a few channels, and this is an area that it's a challenge we need to improve upon. Document templates. So we have a knowledge repository and lessons learned, and a part of that repository are document templates. So again, projects are document oriented, and so we want to make sure that each one of these projects, we're not reinventing the wheel all the time with our documentation. So there's a good starting point. We have templates and we have good go-bys at this point, so the project resources can take that, modify it, and do the next project. I'll come back to knowledge repository in the lessons learned. So in projects, so like I said, in our projects and technology organization, we have a lot of projects in flight, in the funnel, all the time. And so most, if not all of those projects have, automation systems, entire automation systems we have to build and deploy. And in the past, we've had, I don't know if you guys have experienced this, but when you get, like Shell automation team, you get an EPC involved, you get, 15 or 20 third-party suppliers involved, the main automation contractor. There's a lot of interfaces there. And given all the IT stuff, the networking, virtualization, which we've been doing in the most recent projects, it's just a lot of interfaces to manage. And it's never been 100% right. But we have found that we really have to have one of these resources that know IT and know engineering in the project. We call it a PCD integrity project focal point. So we want to get that person into the project at the right time. So in these capital projects, we have multiple phases. In Shell, we call them, there's more than these phases, but the key ones are select, define, and execute. And so define and execute is where the real work happens. Define is where we come up with the designs, and execute is where we implement. So we want to get that resource in there, either late select or early define, so that resource can influence the documentation that's going to result in what we build. And then what happens is this resource becomes sort of not only security, but becomes the network guy. And so when it comes time to start building things, he ends up interfacing and doing a lot of work, both with the main automation supplier and a lot of these minor suppliers, to tie all the network together, and also making sure our security controls are done right. So we have found that's a key, and I'll talk about one of the challenges. It's not cheap, to have a resource like that, and these projects are literally years in the making, 3 to 5 years. And so it's not cheap to have that resource in there, so we have to build the case to make sure that gets funded. Yeah, and lastly, that resource is typically in there all the way through build, through construction, commissioning, startup, and handover. Now, one of the reasons this is important is because when these projects get handed over to the business, then the business is responsible for operating that asset and following our normal standards and best practices about how we manage security controls. And so you can imagine if that comes into the business and it's not built right, it's a really almost impossible task to fix. And so you end up being stuck with something that you really can't operate from a security point of view correctly or easily. And so that's really, really important to get that right. So challenges and lessons learned. So literally the size of Shell was a big challenge. We talked about Secure Plant. I went back and looked. Tyler gave that presentation 3 years ago. I think it was February of 2015. Now it's February 2018. We're we're still rolling it out. You know, it's been years in the making. So that's a challenge. Same thing with all the workforce, large workforce scattered across the globe. We try to do that community building, but it's a challenge. Knowledge management and collaboration. So our knowledge management piece, and this is not unique to our particular discipline, but it's fractured. We have knowledge repositories over there, we have knowledge repositories over here, lessons learned scattered about. So we really have some work to do to try to improve our knowledge management, and that will improve our efficiency and improve our, I think that'll improve our community building and making sure we're not reinventing the wheel over and over again. Technology helps. So yeah, the point of this presentation was not about technology, it was about the process and the people and all these other components. Technology is very, very important, but it's not the only thing. Success depends on having really good people in these roles. Articulating cybersecurity risk. So, for example, in a business, there may be a controls gap, and we need to close that gap. And so we need what? Money and resources. And so, you know, we need to go to the business and say, we need money and resources. And they say, why? Okay, well, so maybe we struggle a little bit with maybe articulating that risk. I think we're getting better. And I think the leadership has a better understanding of what the risk is these days, so it's improving. Same thing on projects. Like I mentioned, that PCD integrity focal point for the project, you know, that can literally turn into a couple of $1 million that we need to fund that resource over 5 years. And so, so again, articulating that to the project manager, why do we need that? So again, we've been successful and we're improving in that area. Risk must be owned by the business. So this is part of the new philosophy, this new business management system we're rolling out. So historically, these assets, they're turning the crank on the HAZID, HAZOP, the stuff they're really good at, you know, understanding the hazards in the project they're working on and building the mitigations for that with their safety systems and fire and gas systems. And this cybersecurity thing, the way we see it is it's another category of threats to the asset. But in the past, it's been like, well, IT's got that. You know, there's a standard, and somebody's going to make sure that gets done. And so, in the meantime, we're struggling with getting that done. So, under the new philosophy is that asset owns that, and they're going to have to learn how to do these risk assessments, not just the HAZID, HAZOPs, but the cybersecurity risk assessment, integrate that into the designs and roll that out. So technology doesn't map cleanly at all sites. So one of the problems with, you know, the reason it takes so many years to roll out a technology like Secure Plant is because we have a variety of infrastructure across Shell. You know, some of it's high performance, some of it has these low-speed WAN links involved, and so we may have performance issues and a variety of other issues. So it's getting done, but there's certainly been, you know, we've had our share of challenges along the way. And it's the same thing for anything else. Like we are, for example, we're looking at, okay, what do we do about analyzing network traffic? Well, let's say we get to the point where we pick something, okay, now we got to roll it out. So difficult to keep up with supplier solutions. We have Secure Plant, and that represents a certain set of capabilities, but our suppliers, they're figuring out innovative ways to manage cybersecurity for their kit. And then they'll interface with a site, and the site says, oh, we want that stuff, and that's good, and that's what we do. We do want to do that. We want to take advantage of these additional feature sets that folks are rolling into their cybersecurity solutions. But the challenge is you know, how do we integrate that in the Secure Plant, or some other way be able to take advantage of those capabilities? Finding and retaining qualified staff. Maybe that goes without saying, but I mean we do leverage a lot of contractors to fill the gaps across Shell, and so it's even been difficult to find, you know, enough contractors to do the work. Engineering and IT working together. I've mentioned that a few times. You know, probably just like everybody else, we have had issues in the past. There's been that IT/OT thing and the silos, but we are working together very closely these days on standards, architectures, and so forth. And they support the process, IT does. And again, it's simply a must going forward, you know, with all the technology that's rolling in from the IT side. So difficult to be 100% compliant with 100% of the controls. That's probably going to be up there 10 years from now. But, you know, I mention it because it only takes that one vulnerability that we don't have mitigated for that bad actor to get in and do his thing. And then last but not least, this probably should have been the first one, you know, IoT, cloud services, mobile devices, you know, wireless networking such as LTE. We are, you know, even within Shell, we have, the IT organization is working on use cases. How can we extract more value from the PCD using these technologies? And so we're working with IT, and we're trying to figure out how do we take advantage of these things, but do it in a secure manner. And I'll just give one example of something I found out recently. It's already happening organically within Shell. So I talked to this guy at a refinery, and I think we were getting ready to do an assessment or something, and he was telling me about this LTE implementation they did. And we have our rules about how network traffic has to go through Secure Plant, all network traffic out of the PCD to any other domain through Secure Plant. Well, they had implemented a monitoring system. It was for rotating equipment, and it was for monitoring seals. So seals are a problem. They wore out, I suppose. And so they set up, they installed the sensors on the rotating equipment. They networked those sensors to a computer. The computer's connected to an LTE modem, you know, straight out to the cloud, to that vendor, not going through Secure Plant. And so I talked to the site focal point, and he said, you know, all it is monitoring. There's no way you can do control from that set of sensors. And so that's what he did. Now we're thinking about that. You know, is it, you know, the risk is that, you know, 2 years down the road, somebody develops another requirement, oh, let's hook that thing up. And now it's hooked up in a way that maybe you have a back door. So we're evaluating that. So the idea is that, you know, is there a use case for having monitoring only equipment that is maybe light touch on the security controls, and your process controlled equipment is the heavy touch? But we're talking about that. We're debating it. And so maybe some feedback on that would be great. And with that, that's all I have.